Okay, here we are. Welcome to Trig Day 1. All right, Trig is something that's going to be coming up a lot in this class and a lot in your, obviously in this class because we're learning it, but a lot in your next couple classes. Okay, whether in a pre-calculus course this comes up a lot, and in classes after pre-calculus as well. Okay, and Algebra 2 courses comes up as well too, some too. All right, so you will be seeing this, okay, for the next couple of years. Having said that, I don't want to put added stress on you guys. I mean, this does come up on standardized tests too. This is pretty cool stuff. Okay, not my stylus. Obviously, my stylus is sick. Okay, it's two-sided. Look, if you can tell. I'll put the cap on. Here we go. I'm getting ready to start. Let's do it. Let's talk to it. Okay. So, why do you use why do you, holy buckets, here we go. Why I suppose right triangles are so important? You think of examples, you would see right triangles daily. We can use right triangle trig to solve for missing side lengths and angle measures. All right. So we could, if you were, now we're not going to actually do this problem, but like, let's say you were working on a house or working on a building. Hey, you never know. And this is the example of a safe versus unsafe ladder. Wow. They will only stand rigid if placed at an angle between 65 and 80 degrees. Is that true? It could be with respect to the ground. If it's at 55, then it is unsafe. Now, how could you test that? That's a great question. You could just bring your little handy-dandy protractor out there and measure the angle. Or you can find the angle by using the lengths of the building and the lengths of the ground. All right, but these real life application problems are going to come up more in day 3. All right, so we'll circle back to this later. Okay. Now, before we can start computing these side lengths and angle measures, we need to understand how to set up trig ratios. So there's 3 important terms that you're going to hear a lot. All right. There's the hypotenuse, which we know what the hypotenuse is. There's the opposite side and there's the adjacent side. The hypotenuse is the side across from our right angle. Across from the right angle. And I'll use the hypotenuse. I'll call that H for hypotenuse. All right, so if here's our right angle, the side across from it, I should make sure you realize that that's the side across from the right angle. This is considered our H. Okay. Now, a lot of times you see all these like A's out here, right? There's an A, there's an A, there's an A. Okay, this A is called our reference angle. Hopefully I'm going to erase that so you can read this better. Reference. Not much better. Angle. Got a battle. It's a reference angle. Okay. So that's the angle that we're going to start at. And you'll understand why that becomes more important later on. But what I want to do from this angle is I want to draw an arrow straight across from it. This is my opposite side. Okay. This we write as an O. So the opposite side is the side across or opposite of our reference angle. So it's the side across from the reference angle. Okay, now, having said that, all right, the opposite side can never be your reference angle will never be your right angle. I'll say that again. Your reference angle will never be the right angle. So the hypotenuse will always be across from that right angle. All right. Your opposite can never be the hypotenuse, if that makes sense. Okay. The hypotenuse is always going to be H. The side across from the right angle will always be H. The things that change are the opposite side and the adjacent side. Okay. So, and what I mean by that is, well, we know what adjacent means. It's the side. And we use A. Now, I know that's confusing because we have this A here, but this is our angle A, and this is the side A. Okay? That's A. All right. This is the side we know adjacent is next to. It's next to our reference angle. All right. And it's the side that is used to form the angle, right? This side is used to form the angle. What I always like to do when I do these, when I label my sides, O, A, and H, I always start with H, then move to O, and then do A last. Okay, so here's what I mean by that. So I know that here's my right angle on all of these. Okay, well, I know that this side is going to be the H automatically. All right, the side that's my reference angle, again, the reference angle is going to be angle A here. That side is the opposite. Well, what's left over? Oh, this bottom side, that's my adjacent side. Okay. Whenever you're solving these types of problems, make sure to label your side lengths. So again, there's my right angle. The side straight across from it is my hypotenuse. A is again my reference angle. Now the reference angle can change. All right. It's not always going to be labeled A either. The side straight across from it is my opposite, and the last third one is the adjacent side. Oops. That's my adjacent. Try the last one on your own. Pause it. All right, so hopefully you came up with this. Be careful about the position of the reference angle. This side is straight across from it. That means that has to be the opposite. All right, let's keep going. Okay, make sure you're marking places that you have questions so that during my, when I'm on there for Google Hangouts, all right, you can come ask me those questions. All right. So let's begin to talk about sine, cosine, and tangent. Okay. Each ratio requires two side lengths of two sides of a right triangle. So these are the three main ratios. Each of these ratios also have reciprocal ratios. Okay. There's 6 total trig ratios, but we're only going to talk about 3. All right. You'll learn about the other 3 later on in your mathematics careers. Wow. Sine is always going to, and there's a trick to remember this. All right, and I'll show you that in a little bit. Sine is always going to be the opposite side over my hypotenuse, or in our case, O over H. Cosine will always be the adjacent side length over the hypotenuse. And tangent will always be the opposite over the adjacent. Okay. What I mean by that is if when solving for a ratio, it says start by labeling the thing. Okay, so we want to find the ratio of our sine of our angle. Okay, this angle here, the T, that's your reference angle. All right, T is our reference angle. That's where I know where to start. Whatever's in the parentheses tells me where to start. All right, this is where I start, and this is where I make the O. Okay. That's where I start. All right. We always know that this is going to be our hypotenuse, and that'll be our adjacent side. Okay. But this part here is where you start. That's the most important part. Okay. So if sine of T is opposite over hypotenuse, or O over H, well, what is O? O is 7, and H is 25. And that's it. That is the ratio for sine in this triangle. That would be your answer to this problem. Cosine is adjacent over hypotenuse, or A over H, which is 24 over 25. Okay, and that's it. That's the answer. Okay. Tangent is opposite over adjacent, or O over A, which is 7 over 24. All right, so whenever it says find the ratio, this is what we're looking for. Finding the ratio. Okay, or if it says find the sine of T, this is what we're looking for. Okay, so if we go to the next page, it says find the sine, cosine, tangent ratios of the given angles. All right, they're talking about this. The given angle is your reference angle. So here, our reference angle is E. So I start at E, and I label this O, I label this H, and I label this A. Okay. Each one of these 3 sets of problems has a different reference angle. So you need to pay attention to that. What I'm going to have you do now, I'm going to have you pause the video and try these on your own, and then come back and check. And I apologize, I forgot to mention, make sure you reduce your ratios. Reduce your fractions, reduce, reuse, recycle. Don't you forget that. Remember now. Okay, so make sure we reduce it. All right. Keep going. All right, here's numbers 1 through 3. Check your work on that. Okay, that's a 30, not a 36. All right. Again, E was our reference angle, so this is my opposite side. All right, try the next 3. All right, so I want you to pay attention here to the reference angle. It said the reference angle was angle D. So angle D is actually up here. So this trips a lot of people up on this problem, on these 3 problems here. All right, so this side, 6 root 2, is actually the opposite, okay? This is still the hypotenuse, and that's my adjacent, okay? So a lot of people will just go straight to E, all right, and then label this the O and the A, but you have to be careful because this can be your reference angle up here as well. Make sure you reduce, all right, 6 over 9, I can reduce to 2 over 3. The root 2 just stays root 2. Same thing down here. 6 over 3 is 2, all right, and then that root 2 just stays root 2. All right, try the last 3. All right, here's the last 3. Angle D again was our reference angle here, and then I drew straight across to find my opposite side. Hypotenuse, remember, is always across from my 90-degree angle, and the leftover side is our adjacent. Okay, so notice how these 9 problems ask you to just find the ratios. All right, well, now as we move back here, we're going to solve for x. Okay, and we're going to want to use our calculators to do that. All right, so there's this helpful trick. I told you there was a trick earlier. All right, we call it SOHCAHTOA. So sine, cosine, and tangent. The S stands for sine, opposite over hypotenuse. C is cosine, A over H, adjacent over hypotenuse. T is our TOA, or tangent, for opposite over adjacent. So I want to do number 11 first, okay? There's a reason for that, and we'll do number 10 after this, okay? So when solving a right triangle, okay, using our angles to solve for a missing side like this, all right, I know that I'm going to have to, shoot, hold on a second. Okay, sorry, I forgot I want to make a change here. I want to make this not a 79. I want to make this here a 22, all right? Okay, so now we have that change made. All right, so like I was saying, so the angle that you're given here, so I'm given that this is 47. Well, that means I want to use that 47 as my reference angle. So this is my reference angle now, okay? So I'm going to label my sides again. I have O, this is my hypotenuse, and this is my adjacent. Well, I only am concerned with the sides that I'm given, okay? So I'm given A and H, all right? Now, I know that A has there's an X there, but that's okay. I'm still given that this is X, all right? So I'm only concerned with A and H. Well, which trig function is A and H? It's cosine. All right, so I know to use cosine because I have A and H. I have nothing for O, so I can't use tangent or sine. So when I use cosine, I mean like this. 47 is our reference angle, so cosine of 47 equals our ratio, XA over H, which is 22. Now we want to solve for X now, okay? Now, cosine of 47, cosine is an operator. Like when I take the square root of a number, like the square root of 4 is an operator. Square root's an operator. It's performing an operation on that actual number. When I take the cosine of a number, I'm performing an operation on this number, okay? So I want to think about this as being over 1, and I'm going to cross multiply here. So x equals 22 times cosine of 47. Now we're going to want to actually figure out what this value is, and I'm going to show you how to do that. You're going to need a scientific calculator to do this, okay? To do this, I'm going to pull up my calculator. So first thing I want to check here, all right, and you can see my keystroke down here, so in case you miss a part. I want to make sure my mode, so I'll click the mode button, and I'll go down to this third line here. I need to make sure that I'm in degrees. All right, degrees is it's the angle measure. All right, radians is also an angle measure as well. All right, but you want to make sure degrees is highlighted, so press enter over degrees. All right, I get out of there, okay, and I need to do 22 times the cosine of 47, just like that, and press enter. Okay, I'll show you that the keystroke there, 22 times the cosine, which is my operator right here, of my angle 47, and I get about 15. A lot of these are going to be decimals, and that's okay. And we can't be afraid of the decimals. All right, there's not going to be a whole lot of exact answers here. So my answer is 15. X is 15. All right, what I'm going to do, I'm going to stop the video here, okay, and I'm going to create a short second video just explaining number 10 because number 10 will come up in the practice problems. All right.